Imagine if you could be anywhere in the world in a blink of an eye. Sounds like science fiction, doesn't it? But this idea, as outlandish as it may seem, is not entirely alien to us. The concept of teleportation has been a staple of popular culture for decades, gracing the pages of comic books, the silver screen, and the imaginations of dreamers worldwide. We've seen it in action, from the transporters of Star Trek to the apparition in Harry Potter. But what if I told you that teleportation isn't just a figment of our collective imagination? The world of quantum physics has flirted with the idea, hinting at the tantalizing possibility of objects being in two places at once. Yet, for now, the concept remains just that, a concept. While teleportation exists mostly in the realm of fiction, could there be a grain of truth in these fantastical tales? Join us as we explore this enigma, journey through dimensions, and dare to dream of the impossible. Teleportation isn't merely a construct of imaginative minds, it has roots in the complex world of quantum physics. Quantum physics, often described as the science of the very small, provides the theoretical framework for teleportation. At its heart are two fascinating phenomena: quantum entanglement and superposition. Quantum entanglement is akin to a cosmic twin connection. It happens when two particles become linked, and the state of one instantly influences the other, no matter how far apart they are. Picture it like this: imagine you have two dice. No matter how far apart you take them, when you roll one and it lands on a 4, the other will also land on a 4. They are entangled. Then there's superposition. In the macroscopic world, we're used to things being in one place at a time. But in the quantum world, particles can be in multiple places simultaneously. This is superposition. It's as if that die you just rolled landed on every number at once. It's only when you look at it that it chooses a number. These two phenomena could, in theory, provide the basis for teleportation. If we could put an object into a state of quantum superposition and then use entanglement to link it with another location, we could teleport it. And guess what? Scientists have already done this. Not with macroscopic objects, I'm afraid, but with particles. In experiments, physicists have successfully teleported information about a particle's state from one location to another. This is a process known as quantum teleportation. However, it's important to note that quantum teleportation isn't about physically moving particles from point A to point B. Instead, it's the information about the particle's state that gets teleported, with the particle at the receiving end taking on the characteristics of the original. Quantum teleportation is a reality, albeit on an infinitesimally small scale. But could this ever scale up to teleporting larger objects or even humans? Well, that's a question for another scene. So, while teleportation remains a theory, it's not entirely outside the realm of possibility. Transferring quantum information is one thing, but what about teleporting a living, breathing human being? Let's delve into this topic and explore the challenges that we face when we talk about human teleportation. The first hurdle to overcome is the Heisenberg uncertainty principle. This principle, a cornerstone of quantum mechanics, tells us that it's impossible to know both the exact position and momentum of a particle at the same time. This creates a significant issue for teleportation, as we would need to know both these aspects to accurately recreate a person at a new location. It's a bit like trying to read a book in the dark. You know the information is there, but you just can't see it clearly. Then there's the problem of reassembling matter. Imagine for a moment that you're a complex jigsaw puzzle. Teleportation, in its current theoretical form, would require breaking you down into your individual pieces, sending those pieces across space and then reassembling them. The challenge lies not just in making sure every piece arrives at the destination, but also in putting them back together in the right order, right down to the last atom. It's a task far beyond our current capabilities, equivalent to solving a billion piece puzzle in mere seconds. Moreover, there's the question of consciousness. Would the person who arrives at the other end of a teleportation journey be the same person who started it? Or would they be an exact copy, with the original effectively destroyed in the process? This is a philosophical conundrum as much as it is a scientific one, and it only adds to the complexities of human teleportation. These challenges present a daunting task for scientists and researchers. They stand as reminders of just how much we still have to learn about the universe and our place within it. Teleportation, in all its mind-bending complexity, pushes the boundaries of what we currently understand and invites us to explore further. As it stands, human teleportation remains a formidable challenge, but perhaps not an insurmountable one. Suppose we could teleport humans. What then? What ethical questions does it raise? Let's begin with the question of identity. Is the person who steps out of the teleportation device on the other side the same person who stepped in? Or have we, in essence, created a clone while annihilating the original? This question goes beyond the realm of science and treads into the territories of philosophy and morality. It forces us to redefine what we understand by identity. Is it merely the arrangement of atoms and molecules, or is it something more, perhaps an unbroken continuity of consciousness? And then there are the possibilities for misuse. With teleportation, the potential for invasion of privacy, or even worse, illicit transportation of illegal substances or weaponry, skyrockets. Who's to stop a malevolent force from teleporting a bomb into a crowded area, or teleporting themselves into secure locations? The implications are chilling, to say the least. Moreover, consider the impact on travel and society. If we could teleport, would we still need cars, planes, or trains? The environmental benefits could be substantial, with a drastic reduction in greenhouse gas emissions. Yet, the sudden obsolescence of entire industries could lead to economic upheaval and job loss on an unprecedented scale. And what about the less tangible effects? The joy of journeying, the anticipation of travel, the thrill of exploring new places? Would these experiences lose their charm in a world where any destination is just a teleport away? Would it make our world smaller, or just more accessible? The advent of teleportation could revolutionize our world, but it would also force us to grapple with profound ethical dilemmas. As we inch closer to making this science fiction dream a reality, we must also prepare ourselves to navigate the moral labyrinth that it presents. Despite the many hurdles, the dream of teleportation persists. What could the future hold? As we delve into the realm of speculative fiction, we encounter a vast array of possibilities. Imagine the profound implications of teleportation technology on space travel. The vast distances of the cosmos, once an insurmountable barrier to exploration, could be traversed in the blink of an eye. No longer would we be confined to our own solar system. We could set foot on distant exoplanets, explore galaxies far beyond our own, and perhaps even make contact with extraterrestrial life forms. The universe would be our playground. Consider the impact on our everyday lives. The morning commute would be a thing of the past. We could live in the tranquility of the countryside while working in the heart of the city. Instant delivery services could revolutionize retail and logistics, with goods transported directly from the factory to the consumer in a split second. But how close are we to realizing this dream? At the forefront of this research is quantum teleportation, a phenomenon that has been experimentally confirmed. Here, information about a quantum state is transferred instantaneously from one location to another. While this is a far cry from the teleportation of large, complex objects like humans, it's an exciting first step that opens up a world of possibilities. Quantum physicists and engineers around the globe are tirelessly working on this cutting-edge field, pushing the boundaries of our understanding. Each new discovery brings us one step closer to the dream of teleportation. Of course, the path to teleportation is fraught with challenges, both technical and ethical. But as we've seen throughout history, humanity has a knack for overcoming obstacles and turning science fiction into science fact. Teleportation might remain in the realm of science fiction for now, but who knows what the future might bring. The possibilities are as boundless as the universe itself, inviting us all to dream of a future where distance is but a minor inconvenience. Teleportation, once a figment of imaginative minds, now finds a place in quantum physics, albeit with many challenges and ethical questions. We've journeyed through the enigma of teleportation, delving deep into its scientific basis. From quantum entanglement to quantum superposition, we've explored the fascinating principles that could make teleportation possible. We've also unpacked the challenges of human teleportation, a task that requires not only technological advancements, but also a profound understanding of human consciousness. The ethical questions surrounding teleportation have been another crucial part of our discussion. From the potential misuse of technology to the philosophical dilemmas it poses, these issues remind us of the responsibility that comes with scientific progress. Peering into the future, we've pondered the role teleportation might play. It could revolutionize travel, aid in space exploration, or even redefine our understanding of reality itself. Whether teleportation ever becomes a reality or remains a captivating fantasy, it continues to inspire and intrigue us. Until next time, keep wondering and keep exploring the universe of possibilities.